Okay, so on this video we're going to use your molecular model kit to address the issue of, are these two molecules different representations of the same molecule, or are they different molecules? And if they are different molecules, do they differ by connectivity, or do they differ in terms of their stereochemistry, that is, their three-dimensional shape? All right, now what we said in class was that when you're faced with looking at a Newman projection and a wedge dash, build a model of the wedge dash structure and then put it in an orientation that allows you to compare it with the Newman projection. All right, so let's look at this wedge dash structure here. We can see that it contains 4 carbon groups, one of which is attached to a hydroxy group, and we have 2 internal carbons that are also attached to hydroxy groups. All right, so let's focus in on our lightning bolt, which is a 4 carbon chain. So let's go ahead and couple these up. Again, when you're coupling them, grab them close to where you're going to couple. Don't push them from out here because you're liable to break the ends off. Grab them inside and push. Sometimes with the new kits, they take a little bit of work in order to put the pieces together. All right, so there's a 4 carbon unit. We want to get this oriented in the lightning bolt orientation, and we want it to look like the picture itself. So this is what we have for the basic 4 carbon sequence here. This carbon is attached to a hydroxy group. Here I already have assembled one of these in our previous discussion, and so what I'm going to do is couple that up. So that gives us that kind of a structure there. Now as we work our way in, we can see that at this position this hydroxy group is coming out of the plane of the paper up towards the viewer. So that corresponds to this position here. And then for the sake of completeness, at that carbon, this hydrogen is going behind the plane of the paper away from the viewer. And of the colored balls, green is the most abundant in terms of number, and so I typically use that for hydrogen. As you get going and a little bit more experience, you may find that you don't want to, you'll leave your hydrogen positions empty. Okay, so hydroxy up, out towards the viewer, hydrogen down, away from the viewer, and both the drawing and the model correspond to that. If we go to this carbon, the hydrogen is coming out of the plane towards the viewer, so that goes on top here. And the OH is going away. So we'll put that on the bottom here. So this is a molecular model of this wedge dash representation. Now, this is in an anti-orientation, but the Newman projection is in a syn orientation, and you'll notice here that the methyl group in front is syn to the hydroxy group in the back, which is here. So what I need to do is twist these two so that they're lined up like this. So there's my methyl in the front, there's my hydroxy in the back, and then what I want to do is look down this bond and see where the other atoms lie. And what you'll see here is that on the front carbon, the methyl and the hydrogens are switched. In the Newman projection, the hydrogen is over here and the hydroxy group is over here, but this is exactly opposite to what's on our molecule. And if we go to the back carbon, we see the same thing again. This CH2OH is here not over here where it should be. So the conclusion from this is that these two representations are for different molecules, and their difference is based on their difference in stereochemistry. So these are two stereochemically different molecules. Okay, so that ends this video and how to use your molecular models to solve these types of problems.